Hello, in this lecture, we will introduce reading from a file. So when you want to work with the information in a text file, the first step is to read the file into memory. You can read the entire contents of a file, or you can work through the file one line at a time. So reading an entire file. So let us start with a file saved in the same directory that contains pi to 30 decimal places with 10 decimal places per line. The file is like this. And the following code opens this file, reads it, and prints the contents of the file to the screen. You write with open pi this file's name as file object. So this statement does open this file and create an object called file object associated with this file. Then with this object called file object is a function called read dot notation read. Then read this information of this file, then assign to the variable called contents. Then we can print the contents, and this is the result of the printing. The open function returns an object representing the file. The read method then reads the entire contents of the file and store it as one long string in variable contents. Notice close is not needed because Python will close it automatically when the time is right. The only difference between this output and the original file is the extra blank line at the end of the output. So the blank line appears because read returns an empty string when it reads the end of the file. This empty string shows up as a blank line. If you want to remove the extra blank line, you can use rstrip in the print statement. So we modify here with open file as open this file as file object and contents assigned with the read function of this object. Then we print contents.rstrip. Print parentheses inside the parentheses with a function called rstrip to the contents. Then the last blank line will be removed. And the file path. Sometimes, depending on how you organize your work, the file you want to open won't be in the same directory as your program file. To get Python to open files from a directory other than the one where your program file is stored, you need to provide a file path which tells Python to look in a specific location on your system. The relative file path tells Python to look for a given location relative to the directory where the currently running program file is stored. On Linux and OS X, you would write, for example, with open test is a directory the same location as your working file now, and in this directory there's a file called pydigits.txt. So we can use with open test and / with this file name as file object to read the file as an R file called file object. On Windows system, you can use a double /. In some book, it tells to use one /, but sometimes it doesn't work. So I put here use double / would be safe instead of a / in the file path. So in Windows we can use with open, for example, test and a double / and pydigits as file object for the relative path. And you can also use an absolute file path to tell Python exactly where the file is on your computer, regardless of where the program that's being executed is stored. So on Linux and OS X, absolute path looks like this: file path /home, then next to find the file, then with open file path as file object. We can put this string for the location to this file path. Then we can use with open file path as file object. And on Windows, they look like this. File path is, for example, D drive : then double backslash and test to find this file. This long string assigned to this file path. Then we can use with open file path as a file object. Then reading line by line, you can use a for loop on the file object to examine each line from a file one at a time. For example, here is the file name in the same directory as your working file now. So we can write with open file name as file object. Then we use a for loop for line in file object print line. So this is a for loop for each line. Can print this line. The file object like a list for each line. This is the result. And these blank lines appear because an invisible new line character is at the end of each line in a text file. The print statement adds its own new line each time we call it. So we end up with two new line characters at the end of each new line, one from the file and one from the print statement. We can use rstrip on each line and print statement eliminates these extra blank lines. So file name and with open, then we write for line in file object with print line.rstrip, line.notation rstrip. Then the print result will be fine. And we can make a list of lines from a file. So when you use with, the file object returned by open is only available inside the with block that contains it. If you want to retain access to a file's contents outside the with block, you can store the file's lines in a line list inside the block, and then you can work with that list. The following example stores the lines of pi digits txt in a list inside the with block and then prints the lines outside the with block. So file name, then with open this file as file object, we can write lines. Lines is a list. Can use read lines. So read lines file object dot notation method read lines will get the information of the file object and assign to the list lines, and actually it will be a list. Then we can use for line in lines print line.rstrip. So we'll have each line in this list will be printed out. And working with the file's contents, after you have read a file into memory, you can do whatever you want with that data. So let's briefly explore the digits of pi. First, we will attempt to build a single string containing all the digits in the file with no white space in it. So this file name is the same, and with open is the same. Then lines is file object read lines get a list. Then we create a variable called pi string is an empty string. This will store the results. Then we use a for loop for this list called lines. For each line in these lines, we will get these lines and use the rstrip form, then assign to the pi string. So each line's information will be rstripped, then assigned to the pi string. So in the end, the for loop finished. In the end, the pi string will be a long string without the white space length. But you can see here also has a one space. So we can print the length of this string 36. So the variable pi string contains the white space that was on the left side of the digits in each line. So we can get rid of that by using the strip instead of rstrip. So rstrip will remove both sides. So here the same thing. Yeah. So only here use the strip. So the result will be fine. And 32 now. Length is 32 now. And large file 1 million digits. The code in previous example would work just as well on much larger files. if we start with a text file that contains pi to, for example, 1 million decimal places instead of just 30, we can create a single string containing all these digits. We print just the first 50 decimal place. So file name now is pi million digits file. This file is stored in the same place with the working file now. So with open file name as file object, we create a list for each line, put in the lines, then start with an empty string called pi string, then a for loop for each line in this line list, get the value of line, and with a strip for both sides of the space, and put appended to the pi string. Then we can print these long strings first 52 string. So that means the 50 decimal places will be printed out, and we can print the length of the string, pi string. It should be 1 million and 2. And the next example is your birthday contained in pi. So let's use the program we just wrote to find out if someone's birthday appears anywhere in the first million digits of pi. We can do this by expressing each birthday as a string of digits and see if that string appears anywhere in pi string. So we can, in addition to the previous code, we can write a statement for input, for user input something. This is a prompt. Enter your birthday in the form MMDDYY. Then user input the value. Six number will be assigned to this birthday. So, and the birthday will be a string. So this 6 number will be a string value. And if we use a test for if test, conditional test. So if birthday in pi string, the pi string is a 1 million and 2 long string. So we can write if birthday in pi string. Then print your birthday appears in the first million digits of pi. Else, if not, we'll print a message. We will try all these commands in Anaconda Spider. We see the file called section 9 files and exceptions py. The file's location link has been added to the description of this video, and the lecture 1 reading from a file, reading an entire file, opens file pi digits, reads it, and prints the contents of the file to the screen. So first we will run this. With open this file and contents get through the read message to this file object and can be printed out with the rstrip. You can see this is the result. We can use a relative path. In Windows, we safely can use double backslash because we save this file to the test directory. Test is in the same directory as this working file. So we can try this. And the result is the same. And we can use an absolute file path. In the dmap, there are test directory and the pi digits inside. So we can run these codes. And results are the same. Reading line by line, we can use for loop for line in file object print line. Actually, there are one more new line for each line. You could remove extra blank lines. Use the rstrip lines rstrip on this, so it will be greater. Then making a list of lines from a file. Can use the reader lines to make a list and assign to the lines list. Then outside of the with block, we can use this list to something to print out, for example. Try this codes. So outside of the block, we can print out line by line. And the next working with the file's content, pi digits, and we create a long string which combines all strings of each line together, then print out and its length. We'll see connected together, long string but has white spaces, some white spaces, and the length is 36. Now here we will remove this using strip, not unstrip. Strip will remove on both sides. I'll try again. Okay, now is better, and the length is 32. We're working with a large file, 1 million digits, and print the first decimal place. So file name is million digits text. So we are the same, actually the same format as the previous code. Run this. So the first 50 decimal place. So we use 0 to 52 index. So the first to the 52's code string will be printed out, and the whole length of this string is 1,000,002. And next we'll check if a birthday in this million. We'll run this code. Try a birthday, month first, for example, 1981, and December 10th, for example. Okay, so your birthday appears in the first million digits of pi.